So 7.6, we're going to be looking at rational equations. One of the things to keep in mind is the domain. So when we solve for x, verify we cannot divide by 0. So if there's any x's in the denominator, we basically have to take that denominator and set it equal to 0, find out what puts a 0 in the denominator. In this situation, there is no restrictions, so our domain would be all real numbers. That's just a symbol that stands for all real numbers. All real numbers. Okay? How do we solve it? Well, we just have a fraction. And I could sit there and try to give them common denominators and mess with that. But the easiest thing to do is just to clear them out. One of the phrases I've heard this called fraction busters. It sounds stupid. But basically, we multiply by the least common denominator. Least common denominator is a number that all three of these could go into. So if I figure out what the least common denominator of 6, 8, and 12 is, and I multiply everything by that, it will clear out. All of the denominators will go into it, and all of the fractions will go away. Okay? So 6, 8, and 12, if you're not sure, I say take the larger of the numbers, 12, and count by 12. Well, 12, well dang, 6 could go into 12, but 8 can't. Okay, keep counting by 12. 24, 36, 48, as many as you need, but find something that both 6 and 8 can go into. Well, 6 can go into 24, 8 can go into 24, so our least common denominator is 24. What are we going to do? We're going to take that least common denominator and we're going to multiply it across each term. I call it kind of like the Oprah effect, right? Like you get a car and you get a car and you, or nowadays, if you're a little younger, maybe the Ellen effect. But the idea is that that 24 goes to each term. So this x gets a 24, this x gets a 24, and this 1 gets a 24. Each term gets a 24. It multiplies or distributes across all the adding and subtracting there. Okay? Well, what does that do for us? Well, I now have 24 divided by 6. That's just 4. That fraction got busted. It is no longer a fraction. I have 24 over 8. That is just 3. And I have 12 over 24. That is just 2. So now I can solve basically using our basic operations. Here I'm going to combine like terms and get that x equals 2. Is it right? I could check. Does 2/6 minus 2/8 equal 1/12? And if you don't like fractions, don't fret. Does 2/6 minus 2/8 equal 1/12? I believe it does. All right. This one's a little different. See, the issue on this one is that now the x is in the denominator. So when I'm checking for the domain, we say, well, the denominator cannot equal 0. We cannot divide by 0. So I take the denominators, the 3x and the x, and set them equal to 0. Technically, we're saying that they can't equal 0. Well, this is one. X cannot equal 0. And this one, if I try to divide it by 3, I still get that x cannot equal 0. So that's really our only restriction. In this situation, a 0, if x were 0, the whole fraction, this whole question would shut down because we cannot divide by 0. Okay, so keep that in mind. The domain, you could just say x cannot be 0, okay? Or you could say all real numbers except 0, okay? So either way, I would be okay with. So what am I going to multiply by here? Well, they all have a 3. This one, you're like, oh, it doesn't have a denominator. Yeah, it does, 10 over 1. So they all have a 3, so our LCD needs a 3. And we keep the highest power of the term x, which is just x to the first power. So I'm going to multiply everything by 3x. Each term gets a 3x. Well, what does that do here? Whoosh, whoosh. Math is more fun with sound effects. 2 equals, whoosh, whoosh. How about 2 plus 3 equals 10 times 3, 30x. Now we just solve. Combine our like terms. divide, and x is equal to, don't forget to reduce that, and how about 1/6? But is it? Are you sure? Right? I always put, well, maybe, because whenever I have an x in the denominator, this answer we could get algebraically, but it may not work. You may end up with what's called an extraneous solution. What is that? A restriction on the domain. Well, the only restriction was 0. Did we get 0? Well, then no, this is the answer. This is the answer. But if a 0 had showed up, which it could in other questions, then we would have not considered that answer. It would have been called extraneous. Just an answer that we get algebraically that doesn't work. Here's another example. First, check the domain. Now, the homework's going to have you separately do this, but I want to kind of merge the two. Take our denominators. Both of them are x plus 2. I'm not going to write it twice. And say, that cannot equal 0. And you're like, no, I got this already. X can't be 0. Well, first of all, x could be 0, so quit that. Because 0 does not put a 0 down here. If I do 0 plus 2, that's not 0. See, that's not the issue. What puts a 0 down here? Well, if I solve this, then x cannot equal -2. So our domain would be all real numbers except -2. All right, so that's just a little side note. What are we going to multiply by? Well, the only denominator, the only group we have there is x plus 2. So everything gets multiplied by an x plus 2. This 1 gets an x plus 2. This 3x gets an x plus 2. And this -6 gets an x plus 2. What does that do? Well, the first one, 1 times x plus 2. How about just x plus 2? Plus, don't start distributing this. The whole point was it clears the denominator, leaving us with just the 3x. And here, don't distribute that. Cancel it out, leaving us with a -6. Now we solve, like terms. 4x plus 2 is equal to -6. 4x is equal to -8. X equals -2. On to the next example, right? Now, I hope some of you stop me, because this is always a maybe here. There are restrictions. What did we say? X cannot equal -2. What did we get? We got -2. That cannot be the answer. So what does that mean in this situation? Well, there are no answers left, so there is just no solution. See, what's the issue? Why is that -2 an issue? Well, if I plug it in, I end up with, let's see. Let me check. 1 plus 3 times -2 over -2 plus 2 is 0 is equal to -6 divided by 0. 1 plus what the heck is equal to what the heck. It doesn't work. So we get answers algebraically. We followed all the rules. It's not like we made a mistake, but that answer doesn't work. This is called an extraneous solution. And since we were not left with any solutions, there was no solution. Onward. Well, check for restrictions. X squared minus 4, take that denominator, cannot equal 0. How do we solve that? Well, I hope you know the F word by now. That is an a squared minus b squared. How about x minus 2, x plus 2? Now I take each of those groups and set them equal to 0. And we get that x cannot equal 2, and x cannot equal a -2. So if I solve this, and either of those answers shows up, we just toss them out. They don't work. They're extraneous solutions. Our second group there, x squared minus 2x. I remember some of you on the test told me this doesn't factor. That needs to stop. These have a like term. Factor out the x. Now what's interesting here is if I take the first group and set it equal to 0, x cannot equal 0. If I take the second one and set it equal to 0, x cannot equal 2. Well, we already got that. So that just showed up more than once. No biggie, okay? So basically our domain would be all real numbers except if I get a 2, a -2, or a 0. If we get those algebraically, they will not be our solution, okay? So what is the LCD here? And I please, 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 I beg you, don't just multiply these by each other. We already factored them. This is what? X minus 2, x plus 2. Don't just multiply them by each other. This is x times x minus 2. So what does that do for me? Well, they both need this x. This one doesn't have one. So the LCD will have an x. They both need an x minus 2. They both have an x minus 2. Okay, so that's part of the LCD. And they both need an x plus 2. This one's missing that. So that's the last part. So x, x minus 2, x plus 2. Okay, so I'm going to multiply that to the top of each one. It's going to be a little messy, but I'm going to go ahead and not just write it up here. I'm going to go 6 times x, x minus 2, x plus 2, all over x minus 2, x plus 2. I'll get back to that, is equal to x plus 1 times x, x minus 2, x plus 2. This seems weird that we're only multiplying it to the top, but keep in mind, the reason we can do this is because we're dealing with equations. I can do anything with an equation, as long as what I do to one side, I do to the other. So in this situation, we can multiply that to the top. What does it do for us? Goodbye fractions. 6x equals... Well, the right side's a little messy. That's okay. We know how to distribute. X plus 1 times x plus 2 gives us x squared plus 2x plus 1x plus 2. So basically just distributing that out. This is a quadratic, an ax squared plus bx plus c, which means I want that set equal to 0, just like we've done in chapter 6. So I'm going to move that 6x over and get 0 is equal to x squared. 2 plus 1 is 3. 3 minus 6, how about negative 3x plus 2? And at this point, the only tool we would have to solve this would be to factor. So guess what? They're going to set them up so they factor for you. You're welcome. Okay? So what that means is we're going to have 0 is equal to about x and x, 2 and 1. To make a negative 3, they'd have to both be negative. When I go to solve this, I get the following answers. X equals 2, x equals 1. On to the next example, right? I hope you stopped me. The key phrase here is we are dealing with a function. We are dealing with fractions. We are dealing with a function that has extraneous solutions. We said x could not equal 2. Did that show up? Yep. Then we toss that answer out. It is an answer we got algebraically, but it is called an extraneous solution. So what is it this time? No solution? No. 1 was not restricted, was it? So that is our answer. We're only left with the answer 1. And onward. And kind of the last thing we're doing is they're going to give us some functions, and they want to just see if you can play with just the variables, solving for a variable. Okay? So 1 over x minus 1 over y equals 1 over 2x. Solve for y. Okay. We still want to clear out these fractions, so we're still going to multiply by the LCD. Okay? So I see an x, a y, and a 2x. So how about a 2, an x, and a y? What does that do for us here? Well, the x's are gone, here the y's are gone, and here the 2x and 2x are gone. That leaves us with y minus 2x is equal to y. Did I mess up somewhere? Yeah, the first one's a 2y. Okay. So that's step 1. We're going to clear out the fractions still. Step 2, we want to isolate the variable of interest. What variable? Whatever we're solving for. The variable of interest. What are we interested in solving for? Y. I want that y by itself on one side. It's not currently. I could move this one over, but since that is already kind of by itself, I'm going to move this one over, even though we got to deal with some negatives. On the left side, I have negative 2x. On the right side, I have negative y. That is not y equals. I still need to divide by the negative 1 and get y is equal to positive 2x. By the way, if you had done it the other way and subtracted the y, you would end up with, y not equals, right? The equal sign's way over here. Y minus 2x equals what? Well, what do those make? Nothing. They make 0. So then I'd have to add the 2x over and still get that y equals 2x. So no biggie either way. And that's going to go ahead and be it. So we're going to have some more complicated things, but work through the homework. Come back with questions, but keep it up, and I will see you guys soon.